but I wanted you to see what I meant anyway, so I'll hold on to this for a second. Where's the... Alright. Does that give a little more meaning of what I was trying to draw on the board? Okay. That's cool. I went to my sink last night. I filled it up with water, and so I had something making a wave here, and so I'm going ding, 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 and I got ding, ding.
It might need to be like a
My
longer.
husband says, I'm standing there for 10 minutes, you know, ding, 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 and what are you doing?
You might need to have like a longer space, like you might have to do it in the bathtub.
It didn't do what they said.
But I'm saying it might have to be like a bigger area, like you do it in the bathtub.
Filling it up.
And you might
I
have
have the flashlight in my mouth.
you can use like ping pong balls. That'll probably work.
It looked rather weird.
Does your husband just learn not to question when you do those things? Yeah. Just like,
Definitely. Alright, so I said something a little off here, so let's go back and correct it. When the two waves interfere, when the two waves meet, there's interference, and the trough meets the trough, it creates a deeper trough. A crest meets a crest, it's a higher crest, but it's not when the half a crest meets half a crest. It's when the crest meets the trough. That's where the cancellation appears. So, when we do that on water, there's a blank spot where there is no wave at all. So we should see the same thing with light if light is a wave. See that little question mark that you can't see? So we're teaching it as light is a wave today. So, all right, so now we get to play with light. You think it was bad with water? Wait till I try this trick. All right, so I'm going to take some light. Do we have half this class in the dark? Seems like it. So here, I'll do it over here on the wall. If it works, Brian will call other people over. You tell me if it works. All right, here you see no slits at all and no banding.
Can you see it?
So we're expecting to see on the wall a light, dark, light, dark, light, dark. So now I'm going to make two slits out of these pencil leads. So all I have is pencil leads, and I showed Brian what it looked like through a solid wall of pencil leads. Why did I pick pencil leads? Because I can make tiny slits between them. So it's a dramatic pause because it takes me a minute to do that. I'm going to try to make two slits and keep the rest solid, which with my dexterity is not very easy. Are you one of the people that can do tiny things and not large motor things?
I usually do both.
So would you rather shoot a basketball or knit a sweater, that kind of thing?
Yes.
Basketball! I am so large motor, it's crazy. Alright. Alright, I think I've got it.
I make bracelets. Like, I don't know how to do that.
Alright, now I've tried to create a slits through here. And what you're doing, Brian, you're reporting on the wall if you see any banding. Like where you see, instead of a horizontal line, you see? Yeah, I don't see it in either. If it works, I'll holler or whatever, but I don't see it working. Alright, well I guess we'll have to watch his dumb video then. How much time do we have?
10 minutes.
Yeah, we could watch the part. What this guy does, he takes a box and he cuts a hole in it and he makes two little slits. And then he makes a viewing window into the box and catches the sunlight. And he asks everyone on the beach to look at it. I'm not going to do that. So I'll try this one more time and then we'll watch the video. I got it to work minimally this morning. Let's see if I can get the banding. Times its angle. I'm not seeing any banding. Well, I'll work work on that. I can get this to work, but not at this moment. So, all right, we'll watch the video. Oh no.
You can do it.
All right, pull it down straight and then out.
Yep.
Oh my goodness, that's so easy. Mr. Stu said to put them all, to pull it to the left, and then someone else said pull it to the right, so now you're telling me pull it forward.
Left and right usually work on like individual ones, whereas the out kind of works with most of them.
Alright, let's see what this guy has to say about, again, we're trying to prove that light is a wave, so, for today.
As this ripple overlaps with those ripples down the bottom.
Alright, we'll start over. Here he comes.
What is light?
What is light? What is light?
Light is brightness. Again,
We have auras,
We all have auras.
which are light.
Yes, they are.
Auras.
It lights up the room. It makes it not dark.
what's the difference between blue light and red light?
Color.
It goes in your eyes and then you see stuff.
The range from white to red to orange to green. It's like the chakras of your body.
Can you see my aura?
No, not particularly right now.
Is it too bright out?
It's very sunny out there today.
Does that make it harder to see someone's aura?
Not necessarily.
If I was to explain it to a blind person, right,
Yeah.
it would be the difference. You see nothing whatsoever as a blind person, whereas I see things in front of me.
You can see everyone has
the
trouble
question of what light
defining
is not an easy one. For centuries, the greatest minds in science debated this issue. In the late 1600s, Newton proposed that light was a stream of particles, or corpuscles. He proposed this in his treatise Optics. But at the same time, a Dutch physicist named Huygens proposed that light was
5
a wave.
minutes.
And this debate raged on until it was settled by the experiment I've recreated today. Thomas Young's double-slit experiment. To make sure I got the experiment right, I went to the original source. With the help of Brady Heron, I managed to get into the vault underneath the Royal Society in London. There I found Thomas Young's handwritten notes from 1803.
Can you hear it?
Sunbeam at a slip of a
Hard
card
with the
about
aura
1/30th of an inch, and observed its shadow, either on the wall or on
Alright, I might have to, because of
optical
time,
distances.
skip
Besides
it
the
forward
fringes
to where
of
he's
colours
doing
on
the
each side of the
experiment.
shadow. The shadow itself was divided by similar parallel fringes of slot dimensions.
This is an experiment so simple that you could make it at home.
Yeah,
and yet so
I tried.
simple that I have never seen it before done with sunlight.
I was thinking about doing it in a box, like a fridge box.
You can take that out.
Taking it out on the street.
Oh, there he goes.
For about a minute. We're doing a science experiment. What I have here is an empty box. And this is a little eyepiece where we can look in. And this is
Would
the
you
hole. Now, I'm gonna
participate
place
if
this
someone
slide
asked you?
above that hole.
Oh, yeah.
If you look closely, you'll
Did he have that good a pair? Yeah.
Alright, you see right there how narrow those slits are? Did you see it?
We need to tilt it towards the sun a little bit.
Look at
Very narrow
that, see that
opening side
slit,
by
there's
side.
two
It's a double
slits.
slit.
That's what I was trying to create with the pencil
Tilt it
leads.
towards the sun a little bit, so we want the sun to hit this double slit directly.
What are we going to see on the bottom?
Well, the obvious thing you're going to see is you're going to see two lines.
Two lines on the bottom of the box, two bright bands.
Two little lines. Yeah.
I think it'll be one line instead of two.
I can expect to see the whole box lit up.
That would be a kaleidoscope of some sort.
A bunch
Of aurora, which is auras.
Tell us.
There, look. You expected to see kind of one line. Is that what you see?
No,
I see dots.
Dots.
it's one circle.
Oh, there's one in the middle strongest, two either side.
Two on the outside are multicolored, one in the middle is just white.
Show
Kind of a
us.
rainbow.
The rainbow of colour as well.
Quite a few colours, but lots of little dots. There are more dots appearing.
I think I can even see more dots spreading along. Yeah, that's amazing. Yeah, I can see tons of dots now.
There, that's what they saw. Do you see the banding?
What's that there?
Either side.
Yeah,
The
definitely.
dark bands is where there's no
Yeah,
waves.
that's incredible. And that's just nothing else apart from two slits. That's incredible. But all we're doing is we're
Incredible.
All right, that's what I was trying to show you in miniature there on the wall. So I'll perfect my technique. All right. So that is convincing us that light is a wave, because if it is, we should see the canceling out, and indeed we do. When we have our experiment set up right, light through two slits does have that canceling effect. So we'll see a band instead of a straight line. So let's probably leave it there. Tomorrow we're going to see that someone came along and challenged that thought, and we will pick it up there. And we'll do a couple problems tomorrow. Sorry, I don't think we did any today.
We did that one.
Oh yeah, I did one, but you didn't really. You enjoyed
You've
it.
got problems, we don't have problems.
All right, over and out, Video Land.